All right, we are back. This is Math 200. This is Chapter 3. We're looking at 3.3. That's on page 9. And I think it's likely we're going to do 3.3 and 3.4. Because 3.3, unlike 3.2, is super short. It's parallel and perpendicular. So look, they want us to just create two equations that are parallel. So let's think about that. Parallel lines never intersect. They keep running forever right next to each other. So they have to have identical slopes. So let's keep it simple. Let's say we've got a slope of 2x plus 3. So that's pretty easy to graph. y1 is equal to 2x plus 3. My slope is 2 over 1. My intercept is 3. And so that's 0, 3. So that's my starting point. 1, 2, 3. I put a dot on 3 on the y-axis. And then from that dot, this means go up 2, that's the directions, and to the right 1. So from that point, up 2 and to the right 1. And then put it down. All right, now, they want us to make up an equation that is parallel to that. Well, to be parallel, there's only one thing. It's got to have the exact same slope. So we need to copy the 2x. But it's got to have a different starting point, not plus 3, anything else. We can make it minus 1, or plus 1, or plus 5, anything. Just not 3, because otherwise it would be the same line. All right, so we need y sub 2 is 2x minus 1. That is a slope of 2 over 1, and a starting point of negative 1. That's 0, negative 1. So that's my starting point at negative 1. And then from that point, I go up 1, 2, and over 1. And then I connect the dots. So those are parallel lines. That's what parallel lines look like. 3, 3, all right? Perpendicular, make up perpendicular. Perpendicular is special. They cross, but not just cross. They cross to form a 90-degree angle. And so there's something special about their slopes. So look, let's stick with this. This worked so well. Let's do it again. So we have it right there. That's a starting point of 3. And then the directions are 2 over 1. So up 2 over 1. There's my line. But the other line is going to be different. Y sub 2, we want it perpendicular. So we have to do two things to that slope. That slope was positive 2 over 1. So our slope is going to be negative 1 over 2. So I did two things. It was positive, I made it negative. It was 2 over 1, I did the reciprocal 1 over 2. X. And now this doesn't matter. You can say plus 3 or plus 1 or plus whatever. I'll do plus 1. It doesn't matter. That can have an identical number if you want. I just don't want it there because then in your notes you'll think it always has to be that way. All right, so now I start at 1, and now these directions, that's down 1 and to the right 2. All right, and my starting point is at 0, 1. So I already put 0, 1 there. From that, I go down 1 and to the right 2. And then I connect the dots. And there's my 90-degree angle. All right, parallel, perpendicular. Awesome. So that was a super short section, parallel, perpendicular. So now let's do 3.4. That is graphing inequalities. So that's graphing lines again, but it's an inequality with a greater than or less than sign. And this is interesting because unlike with a number line, which is the other place we saw inequalities, you could do interval notation. There is no interval notation for this. The only way that you can actually see this solution is through a graph, through a two-dimensional graph. So let's solve it like how we would solve anything for y. Okay, let's grab the slope. The slope is the thing in front of the x. That's negative 2 over 1. That means down 2 and to the right 1. And my starting point is at 0, comma, negative 3. That's the y-intercept. So let's put that down. And let's see, down 2 to the right 1. Down 2 and over 1. Now, stop. Do not draw the line, because now there's a distinction. If it is greater than or equal to, or less than or equal to, we do a solid line. If it is greater than or less than, we do a dashed line. And now why do we do that? Well, it's because as greater than or less than, it's a boundary. It doesn't include the points on the line. Where if it's greater than or equal to or less than or equal to, then all the points on the line also make it a true statement. So it's the difference between a boundary or, boundary, inclusive boundary or not inclusive. So when it's greater than or less than, it's always a dashed line. That's a for sure. All right, so now all of the points on one side work, all of the points on the other side fail. So the question is, well, what side do I shade? Well, do a test point. Let's test. I always try the origin. That's super easy to put in, 0, 0. So we go back up to this original, and I put in 0 for x and 0 for y. And then I see if that gives me a true statement. So is 0 greater than negative 3? Yes, that is a true statement. 0 is greater than negative 3. And so that means this point works, which means all the points on this side of the line work. If that would have failed, if this would have said 0 is less than negative 3, then that point would have failed, and then I would have shaded everything on the other side. So that line always separates all the points that work with all the points that don't work. So let's look at another one here. That was number 1. Let's look at number 2. We got 3x plus 5y is less than or equal to negative 2. So again, we want to solve for y. Isolate the variable, solve for y. So we subtract 3x from both sides. I cannot put it with the 2. It just stays negative 3x minus 2. I divide everything by 5. Ooh, that's an ugly starting point. So we're going to make that into a decimal. We leave this negative 3 over 5x. We make that into minus 0.4. All right? So I've got my slope is negative 3 over 5. That is down 3 to the 5, right to the right 5. And b is negative 0.4. That is 0, comma, negative 0.4. So let's graph this line. We're right there, not quite halfway down. And then from that point, down 3, so down 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. So down 3 and over 5, somewhere in that neighborhood. And then solid line. And again, it doesn't matter if it's greater than or less than. It doesn't matter. As long as it doesn't go through the origin, you can use the origin as your test point. So let's test 0, 0. Back into the original. 3 times 0 plus 5 times 0 does that. Is that less than or equal to negative 2? 0 is less than or equal to negative 2. That's false. That failed. This point failed. 0 is bigger than negative 2. So it's not less than or equal to. So this point fails. All the points on this side fail. So then where are all the points that work? Well, they're down here. And I've had students ask that. They're like, well, no, if it's y is less than, can't I just shade below without doing a test point? Sure, you can totally do that. It's less obvious the closer the line gets to vertical. To me, it's less obvious. I'm not very topographically aware. So if it's obvious to you what to shade without doing a test point, have at it. Just make sure you don't get wrong. All right? If it does go through the origin and you can't use 0, 0, then just use 1, 0 or something easy. You don't want to necessarily use, 10, 10 or negative 15, 30 or something silly. That makes it harder on yourself. Keep it simple, silly. All right, so let's look at 3. X is less than 15. My Calc 2 teacher always said that. KISS. Keep it simple. I think he had a worse word than silly. All right, so X is less than 5. It's an X. Remember, X equals is a vertical line. So if this were X equals 5, we would just go 1, 2, 3, 4, 5 and draw a vertical line. This is going to be a dashed vertical line because of the, it's greater than or less than, so that's dashed. And now less than, what numbers are less than 5? 4 is, 3 is, 2 is, 0, 0. You know, if you try 0, 0 works. 0 is less than 5. So it's everything on this side. If that were a greater than sign, it would have been everything on that side. All right? So we like those verticals and horizontals. Oh, that's brings me up to the next one. Horizontal. Graph y is less than 2. Again, we just go to, it's going to be a horizontal line. 1, 2. It's going to be dashed. And then where are the points that are less than 2? They're down here. All right. And then let's do 2 more here. Graph. And so this doesn't look bad. Graph and test. So that's the vertical. X equals, that's the horizontal, y equals. I know it's an inequality though. That's why it was a dashed line. So now we're going to get all of our sweet skills from graphing. Less than or equal to 1/4 x minus 3. So the slope is 1/4 and the intercept is -3, which means 0, -3. And now we graph it. So 1, 2, 3. Put your starting point. Where are you? At -3. What do I do from there? Up 1 to the right 4. Up 1 to the right 4. Up 1 to the right 4. Put a dot. Solid or dashed line, that's going to be solid. Because of the equals to sign, that equals to sign makes it solid. And now, do I shade above it or do I shade below it? Well, I think it's down here, but let's double check it. Let's test 0, 0, because this is really close to a horizontal line. So if I pop in 0, 0, I put a 0 in for that, I put a 0 in for that, and then I get this statement. 0 is less than or equal to -3, that's false. 0 is bigger than any negative number. Which one's farther to the right on the number line? Is 0 is farther to the right, so that's bigger, not smaller. So that's a false statement, so that failed. So all the points up here fail. All the points underneath work. All right. And then the last one, 6, is, a system. So graph the intersection of x is greater than or equal to 1 and y is greater than or equal to 2x minus 1. They do use this in manufacturing to maximize and minimize profits. Well, maximize profits, minimize waste. So you graph both of these on the same plane. So here, let's do this one in black. Slope is 2/1. Starting point is -1. So I put a dot on -1. I go up 1, 2, and over 1. Up 1, 2, over 1. Solid line. And now normally I go nuts shading like that. Don't go nuts shading. We can test 0, 0. And so if I put in 0 and 0, 0 there, 0 there. 0 is greater than -1. 0 is greater than -1. That's true. So that works. So 0, 0 works. So I'm shading this side, but I'm not gonna go crazy shading that side. I'm just gonna kind of go just a little squiggly sneak like that. All right. Now let's do the other one in blue. That's gonna be a lot easier to graph. That's a vertical line through 1, solid again. And then greater than would be this side, right? Above, if you block out everything else, just look at the blue line. Above it would be over here. And now we only want to shade the parts that they both have in common. So where the two little snakes meet, just on this side of the blue line and above the black line. So that is going to keep growing forever, and then this we would erase. We don't need that. So that is called graphing a system of linear inequalities. We'll look at that a little more in depth, I think in chapter 4 or 5. We do hit that again. All right. And that's it for 3, 4.